All right, everyone. So let's try to learn generative AI and REG. All right, and this video will contain in this one video. What will happen is all you need to know is one video. So if you are a software engineer and you have around 1 to 3 years of experience in working this software ecosystem, and you want to introduce AI to your system, or not system but into this learning plan also, but you are not sure. Like you just go to this LinkedIn or whenever on YouTube, there is like so much to learn. Like you don't feel confident even after spending some times on these tutorials because you're not sure what is actual value that because as a software engineer, especially in today's day, uh, it's not about coding. Trust me, it is not about coding. Anyone, and I'm sure you must have seen these posts of these people who have like less experience in coding and they have just like building these softwares and all. The only thing that separate you from today is that knowing what matters. This is very good skill. Okay, so in today's video, and I also felt this like some days back. Yeah, I'm not AI ready type of person. I don't know why I'm saying this thing, but I felt that I wanted to change it. I thought, let's try to learn it. So I started from the beginning. What does it actually mean when people say generative AI, RAG, and vector and embeddings related things? So I couldn't understand. I thought it's like a very big deal because I didn't understand it. So for me, it was like maybe I need to learn some other things, but it wasn't like that, guys. All you need to do, watch this video till the end, and after this video you will be in a position where you can confidently say I know generative AI, I know RAG, I know embeddings, I know vectors, I know how does all these connects, I know how to build projects using these things. All right, so this video will not be covering entire things of in details because that doesn't make to be on this doesn't make any sense, to be honest, because it's like uh, see, whatever the work in AI that people were doing for the over the years, like 20 years, 30 years, whatever that must have, they are the best in their field. So for example, this LLMs, if you talk about ChatGPT, like Gemini and all of these things, they are the best in their field. So most probably you are not going to be working on some kind of new models. Let's just get it very clear. So don't go into the mathematics of this too much. I mean, of course, it's a good thing if you want to go into the details of that, but it shouldn't be your goal, especially as in your early age of software development. Like I only have 3 years of experience, professional experience. Uh, but if I go to too much, in depth of this mathematics, it won't serve me like really good because people's are like literally you can't believe it, but in 3 months, 6 months, people are learning new technology, new things are coming, and you're like learning basics of these things, and nobody will even ask you in the interview also, and nobody even care in the real world also. People only care about what you can build, and if you say I know but I can't build, then trust me, nobody will hire you. That's it. That's just bottom line. So in this generative AI and all of these things, let's try to learn what problem we are like using this generative AI, RAG, and all of this we are trying to solve, and how it can help you. All right, so let's do it. So let's just assume you want to build a application for a chat application for your team or some organization that has like thousands of documents or uh, PDFs or docs, anything. The data is like vast, but you want to build for that particular organization. So currently what you can do is you can utilize these LLMs. Obviously you are going to utilize them because they are the best in their field, especially in generative things. Okay, so what you can do right now is you can just go to the ChatGPT, or I don't know. I kept saying this ChatGPT, but you just assume okay, I'm talking about this LLM. All right, it could be anyone. You go to them and you ask them their you register your things, and you get the secret tokens and whatever, and then you just have the API, and now in your code you just have the documents, you have the API, you just pass the data, they will give you the result. Just like we do in the ChatGPT also. You can go to the ChatGPT, you can post your resume or your PDF or anything, and you can ask the question about that particular document, and the ChatGPT will give you the answer from that document already. You can just mention, you don't just give me the all the answers, just give me from this document that I shared it with you. It's giving a context. You are giving the context. But as you should know, uh, and you should know by the way, this thing is behind the scene, it's token utilization. right? This is what it is doing. You are giving the some input, they use the tokens to generate the output for you. So some kind of token were utilized. So when you're talking about organization, they must have the limits. So for example, 1 million tokens per day, something like that. I don't know, but it could be anything. But you get the idea. So 1 million tokens per day. Now, if you are building a system that utilizes some third-party external APIs, so our goal is to reduce the tokens utilization. So for example, this is the first one. And now, second thing that we try to solve is, let's just say you have some personal data. You don't want to give to the ChatGPT, right? You will not, and especially if you want to do it thousands documents, you can't put thousands documents to the ChatGPT server. You don't want to do that. So that's the problem now. But we know that these LLM models are very, very good in generative related things. Okay. So what does this? Now you understand the problem, right? Okay, this problem exists, and this is what we're trying to solve. And in this generative AI thing or RAG based, all of these things, this is the main problem that we are trying to solve. That's it. And why do we care about this thing? See, we want to utilize these LLMs, and the reason we want to do it because they are the best. As I've said multiple times in this video, I'm definitely sure they are the best in their field. Like for example, the in text-based, image-based generation, they are the best. So, uh, for example, in NLP, NPL or NLP, natural language process, something like that. Back in the days where these things didn't exist, we utilized that, but they were not really great about this context, understanding the context, or all of these things. They were not great, but these LLMs are very, very good. You can just give them short data, and they will generate you something nice, a response to that. And so we want to utilize them, that power, but we don't want to share personal things. We don't want to give token utilization too much, because we just want to save the cost. And this is interview tips, by the way. So if you are watching this video and if you are preparing for interview, trust me, if you are not sure about anything in the interview, you are like, what should I say, what should be the next word that I should say in the interview, you can say, guys, you know what, we should reduce the token utilization very less, so that we save the cost and all. People are like, oh my god, this guy is like best thing in the world. Interviewer will go like that. So token utilization is less, cost is less, company is happy, you are happy, and the interviewer is also happy. That's the one thing. So always somehow pull back this token utilization. Okay, you want to just uh, utilize the less token, and they will like, oh my god, this guy knows what he's talking about, and you have no idea. But you get my point anyway. So this is what we are trying to do. So let's come how generative AI helps us. This thing helps us. So first, I'm definitely sure you know the generative AI means what it means by now. But if you don't, let's do it. Generative means generating the next like words, images, or something from the existing data. So this is what generative means. AI means obviously the models that were trained on the vast data. So basically, AI means here artificial intelligence, definitely, but we are talking about specific models that can predict the next word or next keyword or next sentence or anything. So, for example, I love dog, I love cat. So, what is the I love next? This is a blank. So, what should come here? This word will be predicted by these models, and they are trained on vast majority of data. Like you can't even billions of data. So, whatever they will predict here, it may not be right. It's not a, this is why I say it's not exactly like this will be right. It could be anything. It could be loin. It could be food. Anything. But whatever that will come, will come from the context. Yeah. Whatever that next word will come, it is probabilistic. So what are the probability of this word of coming here? So this is what these models are trained on, and they are very smart. And why should we trust it? Like for example, Ajay, you said this is probability. Then why should I trust it? How do I know it's right or not? Well, you don't. And why should you trust it? How many times you asked ChatGPT or Gemini and you got the wrong answer about something? You did not, because that's what the proof is. These companies were training, building these models, and we have the results, and the results speak for itself. Although you and me, we are not like that much in engineering mindset yet. You will understand, of course, we are working hard on that. But you can understand, you can trust their data and the response and the results in the market. These whatever they, for example, I'm sure you must have heard about this artificial intelligence, and in that, how do we train all neural network, gradient descendant, to generate the loss function planet. Like there are so many words. You don't understand them fully. Like what the hell is going on, man? I don't know. But These are the exact mathematics things that were used behind these models to build these ChatGPT, Gemini, and all of these things. And we all know how smart these things are. And I'm not talking about proper like smartness in this sense, but generation, text generation, image generation, all of these things, they are very, very good, accurate. All right. So you should trust that this is really good. So instead of saying, prove me first mathematically, then I will only use them. Trust me, bro. This video is not for you. I'm sorry. I can't do that. I'm sorry. I can't do that. So I'm sorry, brother. I can't do that. But if you are impressed, you know what? I love ChatGPT. I love Gemini. I know their works, and I'm sure these are the things that we used behind the scenes also. So why should I fight it? I should just accept it. No. uh, as I said, if you want to go deeper, you can definitely go deeper, but this will be like another like subject. But we are talking about specific use cases. We just want to use them. All right. So now that we understand the problem that what we are trying to solve, why do we care about generative AI and RAG and all of these things? Let's run one by one. And now you know why should you trust these things? Why should I trust? Now come to the point. Okay. So how does this work entirely? So flow is this. Let's try to learn flow first. Let me just take a sip of this tea. Okay, so let's try to learn the flow first, and then one by one I will explain. I'm sorry, listen, I'm making this video after a very long time, and to be honest, I don't have the exact plan. See how should I'm working on the storytelling, but you just stick to it entire the video. So you will just I will cover every point, so that you know what. Okay, this guy didn't cover here, but this guy covered here this topic. So idea is this: you build a chat application, meaning there will be front end interface where input box will be there and response like box will be there. You type something. So for example, you type, you know what, I want to change my password, something like that. So now this query comes to the backend. You take that query, you search into those 100 or 1,000 documents, whatever documents you guys have for internally. You search in them. Okay, what are the best results for this query? Send it to user. That's what we are trying to do. But as I said, right now, if you try to do the text-based searching on your system, you say, you know what, why do I need LLMs for that? I can just do this searching in my documents. Well, try doing it, and good luck with that, because trust me, let's just say, how would you do it as a software engineering point of view? Let's just think about it. Pause this video and think about it. How would you even do it? Let's just say LLM doesn't exist right now, and you think about it, and I will let you know. Okay. Until that, let me just have another sip. Well, I'm sure you paused the video and thought about it. So what is the basic flow? What is the basic flow of doing that? You take the query, and from the request you get the query, and you have this data, like, stored in the database somewhere. You run the search, basic search. You find if this word is equal to this word, this word, this word. You keep doing it. Whenever you find user password, you say, you know what, in this line I find this user password. So let me just do what I just do it. 100 word from here, 100 word from here, or this entire paragraph. Let me just pick that paragraph, because the answer might be here. I picked that paragraph. You do this thing. So let's just say 5 to 10 places. Therefore, this was this user password word you found. Well, this is useful because this is what user typed in the front end also. So you just like you did the very good thing and good job. And now you picked 10 paragraphs. Do you in 10 paragraphs what are the exact steps that the other person should see? You just written this 10 paragraphs to that front end, in the front end you're like, what the hell is this? What do I do with this thing? Where should I click? You don't know. But that's anyway, this is good system, you know what, and you just did a good job, you got the promotion. But what if I'm sorry, but what if I typed or the user typed, sorry, not I, the user typed I want to change my credentials? What do you do with that now? Your document doesn't contain the user credentials, they just contain user password. Now you don't find anything, but you know this meaning of user credential. I want to change my credentials, meaning they want to change, might be they want to they might want to change their profile picture, email, or password, anything. These are the credentials. But your query does not know that, because it's a row. You're literally checking if this words contains this paragraph, pick them, but there's nothing related to credentials. Now you don't say, okay guys, build threading in different ways these credentials. First do the user password, then do the credentials also include. You can't say that. This is just one example. Okay. And in this case, you like not found, but you shouldn't say not found because you know meaning. And this is where, my friend, this LLM can help you, because you know if you put their um, these documents into the ChatGPT, if you ask, I want to change my credentials, you will get the answer, because ChatGPT does not just search on basis of exact meaning. Instead, they search on context based, and they understand the context of what you're trying to say. All right, and this is why we want to use them. But we don't want to like give the like 1,000 documents or security reason or whatever reason as we discussed. Now comes the next picture. But Ajay, how do we do that? Like, like this. Okay, so let's talk about that. So there is something called RAG, Retrieval Augmentation Generative. I'm sorry, I don't know if this is the right thing or not, but the RAG means this. RAG is a process. It's architecture. And what does it mean? Let me just explain you in a minute. I hope this voice is clear. Anyway, okay. Now we want to learn something. So we have established the problem. Now we are facing the one very big problem. But Ajay, how do we do that? Like, for example, when a user search something, we want to call the ChatGPT API. But how do we pass the relevant information to that? Because as I said, if you search on the exact keywords, like text based searching, it will still fail. Like, what do we even pass to the ChatGPT? Because we want to use the ChatGPT, but we also want to give the context to the ChatGPT. Okay, hey ChatGPT, here are the 10 paragraph. As I said, we will send those 10 paragraphs to the ChatGPT, and we will also write key. Okay, give me the answer from this, and ChatGPT will is smart enough to give the answer. But how do we even find that those 10 what do you call that paragraph? That is the problem that we are facing, right? And this is where this entire RAG architecture comes into the picture, which is based on embeddings. Now let me explain what are embeddings. Well, instead of searching into the text base, think about this. What if we convert these text into the numbers? And why do we even convert it into numbers? Well, there's a long story about it, and you can of course search it. But the main idea is, when you search in a number, uh, your algorithms and your these artificial related tasks becomes very easy to do, because they are, your computer understand numbers very much better than we. And instead of just searching exact search text, search similarities. So as gave you the example of I love dogs, I love cats, then what is the next word? I love, whatever the blank there is, what should the next word come here? So instead of this, they will say something like, okay, loin or something. So love, dog and cat are in this upper words, dog and cat. I love dog, I love cats, and I love here. So if I say this, then dog is equal to cat for that, because I love in the next word of I love, again, next word of you know after the love is dog and then the cat. So dog and love, dog and cat are like related, similar, or in the, like, for the computer it's similar. Okay, so whatever the number that we will generate from them, it will be like, okay, this are the related, not exact same, but something similar. So next time if I want to use something like that, and then I should use, then I can trust it. Then I can trust it. So again, how do we generate? So numbers are basically, in the programming we call it vector. Basically, vector into, we store vectors, meaning the array, right? So there are, like, I think there are some dimensions, like for example a single array, uh, but it's not single array. Single array represent this thing, multi dimensions array. And when I say multi, guys, you won't believe it. 500, 600, 700, 1500 dimensions, blood chimka. There are so many dimensions that these numbers are generated, and based on that, we convert our text into these embeddings, and this is what we store into the database also. So instead of storing raw text, we store this entire data of embeddings. Now, how do we convert them? Well, there are very good methods, and there is some method called transformers, ML methods, something like that. And ChatGPT also provide these methods, but I think this transformers ML method, that of course we will be looking into this project that I've already made. So I will explain you there what does it mean. But you can utilize that models to generate the embeddings, and then you store the numbers into this um, like database. So those numbers are called vectors. Basically, what it is, instead of text, they store the like a context based or number based system, so that it represents something. If you look at those numbers directly, that doesn't make any sense to those numbers. Let's just make it very clear. Now, how those numbers are generated? As I said, we can trust these models. Why do we trust these models that generated these numbers? As I said, they are used by these industry experts, and these LLMs, all of these things that you see and you are amazed by these, they all use similar kind of things, the context in generating numbers, and then using the numbers to find the next relevant information. Context based similarity, something like that. That's why we can trust it. Now, of course, if you want to go deeper, you can definitely go deeper, but that's just the idea of embedding, meaning we have the text, we generate into this, we convert into the numbers, into this multiple dimensions of vectors. That is it. So instead of storing that, so that we can do. Why do we do that? Now, here's an important thing. There's something called similarity, like distance. So for example, let's just say there's one vector, there's a second vector. Now, how I want to find out what is the distance between them? Distance meaning what is the similarity? How much far away from there? So the more the the distance gap is, meaning they are not similar. We want the similar result, as I said, and this is what they represent. The distance represent the similarity. If the lesser the distance is, the more similar of being these vectors are closer to that. So that this is what we can do. So we can do this, and there are some algorithms to do that. You can choose it, by the way, cosine similarity, equivalent distance, or things like. Or I'm sure there must be more, but these are the top level that you choose. What it does is basically it compares your vectors to the other vectors and find the similar documents in a like orders. So for example, if you compare two vectors, if they are similar, their gap of distance will be very less, and we want that key. Okay, it means, as I said, I love dogs, I love cats. So when we talk about these, so let's just assume ki there's this vector of I love dogs text, you can assume that, and there's this vector of I love cats. This should have this gap of very less, because they are similar, right? So in the next time we talk about animal or something like that, these two come together, because in the context they represent something very similar, and that is our goal is. Because as I said, when we will search, we will not do text based searching. Instead we will do context based searching. So when we will check user credentials or user password or whatever, those same vectors that we will be generating, and how we will generate them, and what are the strategies, I will get into that in a minute. But this is what we are going to do. So now, instead of searching exact, we are searching similar. So user credential, user password, all of these things will represent the same kind of vectors. So we will pick them. So the chances of now picking the those 10 paragraph that I told you, let's just say, contain this information of user changing password, profile changing password. Now we will pick them by that. Now this is the idea of embeddings, and why do we do that? What are the vectors, and how do we store that? Why do we even do that? Now let's look at how do we generate them. So there is a different strategy. See, you can't convert, like you can convert, by the way, technically, but think about it from software engineering point of view. Let's just say there's this entire document, and if you converted entire document into this vector, right? If you search something, and of course, if you search, that too also will get converted into this embedding, meaning the vector of numbers. That text also will be converted using this same strategy that we converted this document to the vector, and then you store this vector into the database. Okay, nothing problem till now. But you search something, user search something, we convert that text to the vector again, and then we search this vector to the database. Instead of that text, we search, okay, this is a vector that was generated from this query that user created. Okay, this is a vector. Now search against all the vectors and find the relevant information. So let's just say we search it, but the problem is you generated entire like vector using the entire document. So the entire document will get pulled, and we don't want entire document. We just want chunks. That's it, right? Because we want to utilize the token, because the API will use the tokens and context. We don't want to give entire document. So the point is not, so you're not saving it. So instead of that, what would be the best strategy? Instead of creating the vector of entire document that you guys have, create chunks, meaning 500 words. So you have the documents, you pull the documents into the memory, you just read 500 words, and you keep creating the vectors. And what do you store into this vector? Well, there are three things you store. Sorry about that. There are two, three things that you store. First one, obviously the number that was generated, the embeddings. Sorry, I should not say the number. Embeddings is the right term. Embedding that we generated, but it's not a number. So that is plus what was the text that was, this embedding was generated from that text, and then some metadata related to that. I don't know, it could be anything. So you store these things into the database, and the limit length is, you can decide length 500, 300, 200 based on your what works for you best. But this is much faster. Now how is much better? Now search the same thing. You store the data using this transformation model. You just build a function, you give the document, and you just chunking strategy. You use this chunking strategy of 300, 400 words, whatever the words was. And from this point of view, now you store the like entire documents into the database. You stored there. And what did you store there? The vector. And what was this vector was generated from the entire text, and then some metadata about it. These are three things that you stored into the database. Done. Nothing, no problem. Now comes the query. You fetch the query, you again generate the embedding. You don't search exact query, you generate the embeddings. Meaning you create the embeddings using the same transformation model or that strategy that you use to create the vectors or embedding. You have the query. Now you use the searching using the same methods, same transformation models on all of these things. Pass the vector that you generated for that query or embedding that from that query, and give to the database. Now what will happen? Watch this. You will have less documents. You will only have less like 3-4 vectors that match the criteria. So in the 3-4 documents, meaning 3-4 paragraphs. So now instead of the entire document, you have 3-4 paragraphs. Now you go to those 3-4 paragraphs after finding, and you are sure that these are similar to this user query. So you have 3 paragraphs. You extract those paragraphs, not the vectors. Now you, as I said, we stored three things: entire embedding plus that embedding that was generated from the text and some metadata. So we need the text. So we have the text. Now it's still in reg process. Okay, we first store the data. Now the second we search into that, we find it. Now great. Now we get those paragraphs from that, and we build this nice documents, small documents for that. And now we are generating the prompt. Yes, now we will generate the prompt where we will append the user query, like for example something like this. Okay, hey GPT, give the answer from this document that you generated. So you will append that text or paragraph that you got from the database. So you will attach those, plus then you write instruction, only give the answer from this and that was assigned, that is attached to you, give this from that. And then the question, this is the input. I want to change my credentials, you open that, and then entire document or entire file you send it to the LLMs API, and they will take care of that. Now as I said, they are smart enough to know what you are asking, so they will not do the global search. Instead they will just stick to that because they are really smart, and we have all seen that. So now the response will come to you, and instead of just sending the 10 paragraph to the user, you are sending the whatever the response that LLM gave to you. Of course you can fine tune it still, you can check by different algorithms, okay, is it right or not, should I send it or not. But most probably you will not do anything now, that you send the entire input with context attached to it and some instruction, your nice prompt, you send it to the LLM will give you the response, you give the response to the user. Now user will see, okay, this is how you should change your password, click here, click there, click this, because you attach that context to that instead of just entire paragraph where they're like, what the hell I do. Now they're like, oh, this is what I should do. And if they didn't find anything, so they might say, how do I create a how do I don't know, say, how do I disable my account. Let's just see, in your document you have not mentioned anything related to that, nothing. related to accounts, then it will say not found, and that's fine. But that's what we wanted, because we don't want to give the answer always. We can just say not found. That's it. So now you can say, hey guys, update the documents or something like that to your team. That is what entire process from the generating vectors, embedding. Sorry, not generating vectors, generating embeddings, chunking strategy, generating nice, creating new nice prompt, and fine tuning the entire LLMs, response and sending to the user. That entire process is considered into the RAG. Yes. I don't know what the hell is happening to me. Anyway, this entire process of input is coming. You're taking the input, you're creating the embeddings, and then searching it to the database, and then creating this nice prompt, so that LLM can understand and give you the answer. Then you pass into the LLM gives you response, and then you give to this entire process or this architecture is called RAG. RAG is not a one thing; it's entire thing is RAG. So when you generate, so first thing what you do in the application, what is your job as a software engineer? And this is exactly what you will do most of the time. Literally, what you will do is first you will talk about to the teams. Hey guys, what are you building? They are like, what, we have this documentation or this is what we want to do. All right, great, nice. First thing you will decide the what are the models that we will use to generate the embeddings. That's it. Once you decided that, chunking strategy you guys will decide. You will maybe look at the documents, how long the paragraphs are, something like that. You maybe 300, 200. So you will say, okay, this will work fine for us. You will decide the strategy, and then you will write the code. Nothing. Read the file, save the words like 200. As you said, you will decide the strategy of 200 words. As soon as 200 words happen, pass those 200 words to the transformers model. It will generate the embedding. You generate the embedding plus attach those 200 words, and then some metadata, and then push it to the database. That's it. That's what you are doing. Store the data into the vector database or whatever. It could be anything that Superbase you can use, and I think they support very easily, and they're very fast also. So you can just get up running very fast. So once you store the data, good. Now come the query. You write an endpoint to get the query. You get the query. You generate the embedding as using the same transformation model. You got this vector. What you do? You search into the database. Based on this vector, okay, this is embedding. Now search into the database. Find with the similar results. You can find the top 3-4 results, 10, 5, whatever that you want. Like for example, 3 results you want, 3 results, top 3 results. So it will give you top 3 results. You have those 3 results. You extract those text instead of just number. You extract the text. You don't have to extract in some different way. You are storing it, that embedding plus the text and some metadata into this one document, one record you are storing. So you can just extract the text, then you pass it to the next function, whatever that you are, the way you are writing. But the next goal is using those similar text that you got from the database and the query that you are getting, you generate or create a nice prompt which says, okay, you write Hoi GPT or Hey Gemini or whatever that you are using LLM, give me the answer from this I'm attaching this context to you or results, give me the results from this data only, don't search anywhere, and you write in the query, and this is the my query, search from it, and if you don't found anything, just return not found. That's it. You pass this entire nice prompt to the GPT, and GPT will, or whatever the LLM model that you are using, they will handle it nicely. They will give you the response, or you will return to the user. That's it. That's what you're doing. Your job is here to save the tokens. And how do you save it? Well, you should decide the nice chunking strategy, and your goal should be to as less as possible due to the like API call. So, for example, you could say, let's just say there are some like there are some questions that you think doesn't make sense. So, for example, some random questions, so you can just avoid them. You don't need to call the API every time. You can just say, for example, just a user type for the fun. What is a 2 plus 2? And it's a 4. So you will just, it will come to your API, and you can just figure this out. You can just implement these different things where you're like, this doesn't make sense. You don't need to call the API for that. You can just do it for yourself. But how do you do it, and what are the users that you have, and there are different things. Your goal again is to make sure you don't call the API unnecessary of LLM, because that require token. So even though you are saying, and if you are calling it, call it with less context, less, so that it uses a less token, because our goal as a software engineer to save the token. Okay, that I'm serious. This is exactly what your job is. You're not doing some special thing. You're just calling the API. But now you understand. Now this entire thing is generative AI, RAG, vector embeddings. Everything is covered, and this is how you build the application. That's it. That's is that is it, ladies and gentlemen. And to be honest, there's nothing exciting about it. It's just to know it as a software engineer. Okay, okay, this makes sense. Okay, this is what you do. You write the API, right? You already know how to write API, so there's nothing new for you. It's just okay. So now instead of searching text based, I'm searching in the embedding format where it's a number. So I generate text to the numbers. Then on the numbers I search. Now how does these numbers and vectors everything works? Definitely you should go deeper, and you should learn from this ChatGPT and all of this thing. Go and let them do this hard work for you to understand, make you understand. But the goal was we can trust them, and the reason we can trust them is, as I said, there are these big models, they're already working fine for us, and we have the results. So results speak for themselves. So these are the strategies that they are also using. This are into this RAG architecture. The goal is to make sure you are choosing the right strategy for your chunking state. That's very good. What are the database that you are storing, and how you are like processing it. And you don't want everybody calling random things. You can just rate limiting becomes very easy key. You want key only 10 people can 10 in the 1 minute people can only call certain times. There are different things you can do. If the goal is we want to use the less tokens and utilization, and we want to provide the context very accurate, so that it doesn't uh, like give us random results. All right. Now there are lots of problems also, like for example hallucination. There's this very big problem in the rig, where if we are not careful about finding the similar results, they might give you some random results. You need to take care of that. So the document that you are passing using, that should be in a like in a nice format. All right. So but that's just for the another video. But in this video my goal was as a software engineer to look at it in from top key. Okay, I already know how to build applications using APIs and all of these things. I just want you to understand this so that I can utilize them. So it won't take like 30 minutes of your time. So let's go into the project and let's try to see how did I build it. And it's going to be very simple. Whatever that I explain, remember those things. I will explain you one by one. This is where this is used. All right. Let's see. Let me switch screen and face. Yes, I hope you can see my screen. Okay. Sorry about that. And let me open this front. Yeah, this backend. This is front end. I hope this is live. I don't know. I put it on Versal. Hey, this is live. So basically, you ask the question here. You upload the file, and once you upload the file, you can ask the question about this file here. This was my project, and I stored this into this. Uh, it's nothing. It's very simple API calling. After that, I just uploading file, and for that searching. There are two endpoints that I have called. Let's go to this. And if you want to see, you can see the code also. Like for example, there's nothing app.js, and there is nothing like special going on. It's just this backend URL, and I hope this is not disturbing you guys. But I'm just taken the format. It's upload document function, which does nothing but take the file and it upload. It call this API, which is this upload method using this data and body into the body. It pass the form data. I take this data and I convert it. I convert it into this embedding role, which we will get into that. And the next function is async ask question, which is take the function, send it to the UI, but on a API, but call this ask endpoint. That's it. That's just what it is. And now that let's come to this DB, not sure backend path, and I don't know how to. Okay, good. So this is my main file, and obviously it's basic like a sorry Express server. Nothing exciting about it. See, here is the router I use. So let's go to this routes, and yes. So this is where this upload endpoint is written. So what it does, it's take this file from the whatever that I passed. All right, and here is the insert into document ID. Full query insert into documents ID name value, value against original file name. Okay, so I am storing two things. First, the document ID which I generated it, and whatever the document name is, so I am storing it there. And now comes this important thing, which is chunk text. Remember, I told you, you take the document and you, using the chunks, you create the embedding. So first, this function will give me the chunks, like for example 200 word, 300 array of 200 word, 300 words. And this is, there's nothing exciting about it. You can just go to this chunker.js. What it is doing is, I have a like chunk size of 100. So basically it will break the entire document into this array of 100 words. I hope it's clear. And that's what this code is doing. So you can, do it yourself. But let's come to this again. Now I have this array of 100 words here, and then what I'm doing is creating this embedded chunk. This is very important now, and this is very interesting also. So first thing is, this is where I'm passing this a single array of 100 words, and this will give me that. Remember, I was talking about embeddings and all. This is what this function, embedded function, will give me. And if you go to this embedded function, which is in local embeddings, okay, yeah, it's nothing. It's just, I'm literally passing this as a text. Extractor is not extractor. This is a transformation, that model that I was talking to you about. This is what you get this model from here. And I am just calling pipeline feature extraction. What I don't know. And this is the model's exact name, mini LM L6V2. And now how do they work internally? I don't really know. I mean, I know that they generated, but this is what they will. You pass this, you do this thing, and it will give you that embedding of numbers that I was talking to you about. And you can come here again. And once this embedding is here, all I am doing is this document ID content. Remember, content is, what is content here? Okay, where is this? Chunk. I'm creating this. I have this field in database, which is ID, document ID, content, and embedding. I told you, in every record you have 3-4 things that you store: embedding, actual embedding, and that content that this embedding was generated from, and some metadata like document ID or whatever that you want to do. So I'm storing this exact chunk, that which is the words, the 100 words that help me to generate this embedding and this embedding. So I hope that is clear. And once I do that, I'm just keep doing it using the loop. So entire document will be saved there, and that's it. After that, I'm returning success. Now comes to the asking endpoint. Imagine when people ask the question. So user asks the question, I extract that question from here. Again, I'm using the same embedded method. Remember, I told you, I will use that. I will extract that query of user. I will still call this embedded method, which will return me the embeddings or the vector of that number of that instead of this text. Okay, this is what I need to search into the data. Then what I will do is, I will literally searching here. See, select content from chunks. This is chunks, by the way, is table name. Order by embedding vector. This is how you search embedding vectors, and I'm limiting to 5. You only take 5 similar results, and this embedding and that we generated from this query embedding. So I'm just passing here, use this query embedding and search against all those records that I have stored there. That's it. That's all I'm doing. It will give me this content of that into this result of 5 most topmost results of the similar result. So instead of like a vector, I will get here is chunks, meaning I need the text that this embedding was generated from. So I will get that, and then if there is like 0, then again, as I told you, you don't need to call it every time. So this is like a basic hack that I did it. If the row is length is 0, meaning there was nothing that we found into the database similar to this vector that we just searched, and we don't need to call into this case, we don't need to call the API, right? But currently I'm not calling it here, but see, I have commented it down because I don't want to you just to utilize it like randomly. But as you can see, you can just attach this ask LLM, and if you go to the ask LLM, it's written into llm.js here. Ask LLM. Here's the I was talking about. Once you get the result of these 5 or 6 similar results, you generate a prompt, right? I told you that. So here's the prompt, guys. You say answer only from the context below. If not found, say not in document. This is what a context, and you return the context, whatever the context that you found. What is context? Whatever those results, that 5 results that came from the database, I'm attaching them here. And then question, the question that user searched, actual original question, that I'm attaching here, and that's it. I'm just calling fetch OpenAI, exactly this OpenAI, like endpoint, and passing these necessary things, open API, URL, whatever that is. I'm passing that. I'm passing that, and once the result come, I will response.json. I will just return the choice as 0, first choice, whatever the first choice is. I will just return the content of that, and I am definitely sure that this will return with a nice response. So that's it, guys. And let me just switch back to the face cam. Okay, and that's just it. Your entire front end backend. How does this connect? And I've shown you here. I will link down that GitHub repository so you can check it out. But that's just it. Now, no matter how complex your project is, this is exactly what you will be doing. Now, the neat and software engineering point of view here is that, as I told you, you need to make sure you will only call the API. How do you make sure you will only call the API of this LLM when necessary? This is what first thing you should focus on. So you can definitely put so many, you know, different things depend on your goal, or in projects, that how can some people misuse it, or if there are some questions that are like, I don't know, there are some questions which is like, if not related to this search, then don't answer them, because you're not going to find anything there. So why waste their putting rate limiting? So only in just one day you can just answer 5 to 10 times, and things like this. And this has become very important once you deploy it for the live, because people will misuse it. So you just don't want to do that. And yeah, that's just it. So this becomes, so it's not in your control. So embedding generation, you don't write this code, you'll just use some models. But you just need to understand what's happening. Okay, this is what we are doing, that's it. And of course, second, again, prompt generation is in your hand, obviously. But how does LLM will handle it, how the response they will give, it's not in your control. You just, so there's nothing in control. But by knowing these things, okay, this is how this thing moves. First generate the embedding, then store them in there, and why did we do that, the motivation behind it. You can just kind of get this idea, okay, the goal is here to save the tokens, and find the right context so that we get the right answer. And very less context, if you, let's just say you are test 1,000 words, of course ChatGPT has to do some kind of like thousand, read the 1,000 words, and they will also do this embeddings, planting kind of whatever, and they will find it. So they're utilizing the content. But what if you just return to like, give that ChatGPT like 200 words, they will do less work. So you token will be utilizing very less. So the goal is here. So how do you find a better strategy? Maybe there's something that you can do. Some, but once you know these things, then all the doors get open. Okay, so I think that's it, guys. And if you, it's on weekend, so I hope this weekend was very useful for you. I'm just going to upload it into like 6 p.m. and in 30 minutes I will just upload it raw. I don't care. I'm like, I'm done. I don't want to edit anything. It will be live, and I think you can just enjoy this video. And tomorrow is Sunday, so if you are watching tomorrow, you can definitely see that now everything makes sense. I hope everything makes sense. Now you at least like, you know what, I can talk in an interview what are you saying. But there is definitely go deeper if you want to go. Like for the fun part, just definitely go deeper into these vectors, and how do they generate, what's happening behind the scene, why does it make sense, and what are the strategy. Remember, as I told you, there is hallucination related things happens. Hallucination mean the model thinks something of some other data. So for example, it's like, okay, this is not right. We don't want to do that. We don't want to give some wrong information to the user. And as I said, it's not text-based searching, so we can't. It's a probability. So obviously, there might be these cases where it's probabilistic nature. It says that you can't just avoid this thing, but you can minimize it. All right. And with that being said, thank you so much for watching this video. I know I'm making this video after a very long time. So by the way, you can just cut this video here if you appreciate for learning. I'm just going to rant something about it. I know I don't have time to make these videos, to be honest, and I am trying my best. So today I just like, you know what, let's create the video. I don't care. So that's why I'm recording it, and I I just wanted to do it for a very long time. Trust me, it's like 1 week or something like that. Just I've been thinking, I will do it, I will do it, I will do it. I've been planning and all of these things. I will create this video, then this video, then that video. Then I'm like, you know what, let's just go create an entire video in just one go, and we will see what happens. And it's like 15 minutes of video. I don't know who's going to watch this video, but at least it was very refreshing for me to explain this thing. And obviously I'm preparing for the interview. So if you know anyone, by the way, this is very important, if you know anyone who's looking for software engineers, I am looking for job. I have 3 years of experience as a professional, like, but I have been working as a, like, I don't know, 6 7 years by now. I just love building things, and currently I was exploring this generative AI things. I built this project, and yes, I'm going deeper into that, learning how can I utilize this thing. It's fun journey, to be honest. And so if you're looking for someone, or if you know someone who's hiring, definitely recommend me. And I don't know where you are watching this video, on the LinkedIn or uh, I don't know, like on YouTube. Uh, Leave a like, comment, or whatever you want me to make a next video on that. I will definitely love to do that. See, right now I don't have motivation to do that. I mean, I study a lot. I love studying. I can definitely share some tips with you guys related to how to study. That's genuinely helping me in preparing my software engineering. See, not everybody is working on this like big problems, scale related problems. Like millions of users are coming into their application. So, in an interview, they expect you to design system for that. So, how do you like learn this thing? And I can help you with that. I am learning it, and I think I'm finding it very interesting. So uh, do let me know what you think. And if you watched till that, thank you so much. It really means a lot, and I'm definitely wish you very good luck. Whatever your like goal was, you watched this video till that. And if you watched till that, come to the LinkedIn, say hi to me there, and just mention this key. Hi Ajay, I've watched your video till end. And I don't know, it's a good thing. I don't know why did I just say that, but have a nice weekend, dost, and thank you so much.